Okay, so we're going to look at some more law of sines and law of cosines examples. So let's start with a case where we can actually have two triangles with the given information, I believe. So I'm just going to draw a rough sketch, not drawn to scale, of triangle ABC, with side A being 12.4, and side B being 8.7, and angle B being 36.7 degrees. So if you watched all the other videos, you know that this is the side-side angle case, so there may be two triangles. This is the side-side angle case. So there's either going to be 0, 1, or 2 triangles. So I go through in the videos online how to do this using the law of sines, and to determine if there's multiple triangles, but I'm going to use the law of cosines here to determine if there's multiple triangles. So since I have angle B given to me, I'm going to use this version of the law of cosines, that b squared equals a squared plus c squared minus 2ac cosine of b. Sorry, the handwriting's a little bit messy. And so I'll substitute in here, so I get 8.7 squared equals 12.4 squared plus c squared minus 2 times 12.4 times c times the cosine of 36.7. And I'm running out of space, that should be right there. So now, if I look at this carefully, if I subtract 8.7 squared from both sides, I'm going to have a quadratic equation in c squared. So I'm going to have 0. That didn't come out very nice. Hold on, let me erase that. I'm going to have 0 equals c squared minus 24.8 cosine of 36.7 times c. So I'm just kind of rearranging the 2 times 12.4 times c times the cosine of 36.7. Multiplication is commutative. So I'm just rearranging to have to make this sort of look like a quadratic equation. And now I've got this 12.4 squared minus that 8.7 squared, because I subtracted 8.7 squared from both sides. So I get plus 78.07. So that is a quadratic equation in c squared. It just seems a little bizarre because my coefficient on the c term is negative 24.8 times the cosine of 36.7. But remember, the cosine of 36.7 is just a number. So that coefficient is just negative 24.8 times a number. So it just looks maybe not like a quadratic equation just because I have the cosine of 36.7 written in there, but this is just a quadratic equation in C. So now I'm just going to jump to my calculator. I'm going to graph the parabola y equals x squared minus 24.8 cosine 36.7 x plus 78.07 and find the x-intercepts just real quick on my calculator. So I'm finding those x-intercepts from the graph, and those are going to give me my values for c. So c equals 14.4998, so 14.5. And c also equals, I'm just doing the intersection right now on my calculator. If you hear me clicking a lot, that's just me moving the cursor on the calculator. And c also equals 5.384. So since this quadratic equation yielded two positive values for c, that means I'm going to have two potential triangles. One of those triangles is going to have side c being 14.5, and the other triangle is going to have side c being 5.384. So I'm going to go back up to this first triangle I've drawn, and just put one of those sides for C in there. It doesn't matter which one I do first here. Make C equal to 5.384 up there. And now I'm going to continue to solve this triangle. Now I've just got to be really careful that if I use the law of sines here to find these remaining two angles, I've just got to be careful that I don't solve for the biggest angle, because the sine inverse function never outputs an obtuse angle. So I don't want to sort of be fooled here. So looking at this triangle, it looks like the only possible obtuse angle would be angle A, because side A is the biggest side, and the largest angle is always opposite the largest side, a fact you may remember from geometry. So I'm going to go ahead here and solve for angle C. So I'll do the sine of C over 5.384 equals the sine of B, which is the sine of 36.7 over 8.7. So I'll multiply both sides by 5.384 and then take the sine inverse of both sides, and I'm going to get that angle C is 21.706 degrees, which would make angle A 180 minus 36.7 minus 21.706. 121.594 degrees. So I have solved the sort of first triangle. I found side C, I found angle C, and I found angle A. But now I'm going to need to go back and solve for the second triangle. So I'm sort of running out of space here, but I'm going to try to make this fit because I don't want to change the slides. This might get messy, I apologize. So I'm going to try to squeeze this into this little space here. So I'm going to redraw the given picture, and starting with those same givens, but now I'm going to use that other value for side C, which was the 14.5. And now I'm going to solve for angles A and C again, but this time I'm going to solve for angle A first. So, because angle C could be obtuse, because it's opposite the largest side in the triangle. And remember, the sine inverse function does not output obtuse angles, because of the range of the sine inverse function is negative 90 degrees to 90 degrees. So I'll write the equation: the sine of A over 12.4 equals the sine of 36.7 over 8.7. I apologize for the messy handwriting here. I'm going to multiply both sides by 12.4. And take the sine inverse of both sides. I get that angle A is 58.407 degrees. And then I'm going to solve for angle C, but angle C will just be 180 minus 36.7 minus 58.407. So angle C is 84.893 degrees. So I have solved for all of the sides and angles in the second triangle. So again, you could do this how I did the original videos, using the law of sines, or you could solve the triangle this way using the law of cosines. It's really personal preference. So I'm going to move down here, see if I can move the slide down to number 2, but I appear to be drawing on the slide by mistake. So I'm going to slide this up. Still getting used to this software. And maybe I can erase some of these rogue lines here. doesn't seem to want to erase there, so I'll just leave those there. So I'm going to solve triangle WMN here. Triangle WMN, given that angle W is 37 degrees, side N is 12 meters, and side M, it's 14 meters. Probably shouldn't have picked the units to be meters since one of my sides is little m. That's a little confusing, so sorry about that. So this is the side angle side case. So I'm going to use the law of cosines. I'm going to solve for side W. So W squared equals m squared plus n squared minus 2mn, cosine of angle W. So some substitutions here. So it will be 14 squared plus 12 squared minus 2 times 14 times 12 times the cosine of 37 degrees. So I'm just going to, in one shot on my calculator, evaluate the whole right-hand side and then square root that. So I get, I'm just going to type this in here so you might hear me clicking away. That side W is 8.465 meters. And now, again, if you continue this problem using the law of cosines to solve for the angles, great. You'll get, the angle values. Some people at this point like to switch over and start using the law of sines, which is fine. But again, we have to be a little bit careful here that, so looking at the three sides of the triangle, which we've solved for, side M is the largest side. Therefore, angle M is the only angle that could be obtuse. So since angle M could be obtuse, if I use the law of sines, I don't want to solve for angle M, because again, the range of the sine inverse function is only negative 90 degrees to 90 degrees, so it has trouble detecting those obtuse angles here. So I'm going to use the law of sines and solve for angle N first. So the sine of N over 12 is going to equal the sine of 37 degrees over 8.465. So I'm going to multiply both sides by 12 and then take the sine inverse of both sides. And I get that angle N is 58.554 degrees. And that means that angle M I sort of get for free. I mean, I say that I get it for free, but I do have to do some math. It's just going to be 180 minus 37 minus 58.554. So angle M is 84.446. So in this case, it turns out that angle M is an acute angle. So if I would have used the law of sines to solve for angle M in this case, I would have gotten, I would have been fine. But in starting the problem, when I was determining which angle to solve for between angle N and angle M, I didn't know if angle M was going to be acute or obtuse. So, I played it safe, solved for angle N, because I knew that that was going to be acute based on the sides of the triangle. So you've just got to be a little careful in terms of, when you're using the law of sines. You just have to be sort of mindful. So let's finish off questions 3 and 4 of this worksheet. So question 3 is asking us to find the area of triangle WMN from problem 2. So let me just re-sketch the given information here. Angle W was 37 degrees, side M was 14, side N was 12. So notice there's a couple of ways that we can find the area of a triangle. We could use the traditional formula, which is 1/2 base times height. But that might be a little bit tricky here because I don't know the height, so I'd have to solve for it. Or I could use the formula that the area equals 1/2 the product of two of the sides and then the sine of the included angle. So I could do 1/2 side m times side n times the sine of angle w. So I think I'm going to use that because I'm good to go. I know side m and side n and angle w, so I can just use that formula. I also could use Heron's formula, which involves knowing all three of the sides, and that is the square root of s times s minus w times s minus n times s minus m, where s is half of the perimeter of the triangle. That would be m plus n plus w divided by 2. So I've got three sort of options there, and then, you know, if I have to find the area, I'm just going to pick the easiest one, so that's definitely going to be this one for this case. If I was given all three of the sides, I'd probably pick Heron's formula. If I knew the height of the triangle already, I'd probably pick, or if I knew one of the heights, one of the altitudes, I'd probably pick the 1/2 base times height to find the area. So it's just a matter of picking whatever's easiest for the problem. So I'm going to compute the area is going to be 1/2 m, which is 14, times n, which is 12, times the sine of 37 degrees. Just make sure your calculator's in degrees here. And that's going to be about 50.552 square units. And the units weren't specified in this problem. So that's the area of the triangle. So let's move on to this last problem, which is solving triangle RTY if we know two of the angles and side t. Let's just erase that. I'm just going to move this up a little bit to here. So now I'm going to sketch triangle RTY, of course not drawn to scale. I know angle y is 37 degrees. I know angle t is 102 degrees. And I know that side t is 12 centimeters. So it looks like I know two of the angles and one of the sides, so I'm going to end up using the law of sines for this case, and I believe there's only going to be one possible triangle here. So the first thing I'll do is I'll just figure out what angle r is. It's 180 minus 37 minus 102 degrees, so angle r is 41 degrees. And now I just need to do law of sines to solve for side y and side r. And remember, I'm usually cautious with the law of sines if I happen to be solving for an angle, because the sine inverse function does not output obtuse angles. But I don't need to worry about that in this case because I know all of the angles of the triangle. I'm just solving for the sides, so it doesn't matter if I solve for side y first or side r. So we'll do sine of 102 degrees over 12. That's sine of t over little t. That's going to equal the sine of r over the side length of r. So if I cross multiply and solve this, it's going to work out to be r sine of 102 equals 12 sine of 41. Divide both sides by the sine of 102 degrees, so r is 12 sine of 41 over 102, and let me just take a moment to evaluate that on my calculator. And I just realized I'm not being too careful here. That should be in the denominator. That should be the sine of 102 degrees. So that makes side length r 8.049 centimeters. And then I could do a similar process to solve for side y. So I'm just going to come up here, see if I can squeeze this in. The sine of 37 degrees over side y is going to equal sine of 102 degrees over 12. So that means that y will end up being 12 sine of 37 divided by the sine of 102. So side y will be about, let me just grab my calculator here, 7.383 centimeters, and I've solved for all the sides and angles of the triangle, so I am done. So hopefully these examples will help us become proficient at solving triangles and finding the area of triangles using law of sines and cosines and all of our various area formulas.